Live streamed, yeah.
So
this
with
one
the
seems to be
original link-
moving. This one seems to be moving. There we go. We're live. Okay.
Excellent.
Don't
Congrats.
know what have no idea what happened there. But sorry for the delay, everyone. But welcome to Climate Chat. I'm your host, Dan Miller. And today we have a really special show. We have a special guest, Leon Simons, who's been on before. Wait. I have to. I'm sorry. I had an echo there that I had to get rid of for a moment. There we go. Sorry. We have our special guest, Leon Simons, who's been on with us before, and it's great to have him today because one of the subjects we'll be talking about is a recent white paper that climate scientist James Hansen and Leon Simons and a couple of other folks published earlier this week, which was sort of like an update to the global warming and the pipeline paper that they did last year that we've talked extensively about. So with that, welcome, Leon. Great to have you here.
Thank you. Hi.
Yeah. So let me also take care of a little bit of business here. Welcome, Eli. So this paper, the world will cool off a bit and other good news. To be honest with you, when I read it, the good news part was I felt somewhat lacking and stretching it a little bit to call it good news. But I mean, I understood what Jim was trying to do. He wanted to provide a little bit of an optimistic, presentation to some degree. I would say the major good news that was embedded in this white paper, which was a very tiny part of it, was that the groups, Our Children's Trust and Earth Justice, filed a lawsuit against the Hawaii Department of Transportation to force them to lower their greenhouse gas emissions. And I guess they won that lawsuit or are in the process of winning that lawsuit. And so that was considered a small but significant step forward. And I'll certainly agree with that it's a small but significant step. We need a lot of big steps too to deal with what's going on. And today we're going to talk a little bit about the paper, and then Leon actually has a lot of interesting information about what's happening right now in terms of what we would call weather, but that weather is driven by changes in the climate, and it's really getting dramatic, getting harder and harder to ignore, even though we try really hard to ignore it, I think. So let's see, Leon, you helped write this paper, but I did a summary of it on Twitter. And so maybe should I say some of the major points and you can comment? Does that make sense?
Yes, go ahead.
I think we're going to go through this fairly quickly and we can get over to the stuff that you have. So one of the points that, again, a link to this paper is in the YouTube description. It's also, if you go to my Twitter account at DanMiller999, you can find the summary of this. Oh, we have Elliot joining us. Great. Welcome, Elliot. And so he starts off by saying that there was an article in the Hill sort of magazine by Jonathan Overpeck, where the article says, if we start cooling soon, in other words, if the global average temperature drops a little bit going forward with the La Nina coming up, then that means that the incredibly high temperatures we recently saw are basically all due to El Nino. That was sort of the gist of the article. And Jim says, and Leon, you're part of this, says that's not true. The world will start cooling soon because we're going from super warm conditions with the El Nino to somewhat cooler conditions with the upcoming La Nina. But that doesn't mean that all that crazy warming was due only to El Nino. It could have been due to other things as well, and the previous papers have talked about that. So the rate of global warming, in other words, how much we're warming every decade, is accelerating, even though global temperatures are soon going to decline. And the physics driving the warming is understood to be two major things. One, we're increasing greenhouse gases in the atmosphere on a constant basis. They're at a record high right now. And also, we're cleaning up aerosols or smoke particles. You can think of that from ships and coal plants. We're cleaning that up to improve human health, make the air cleaner.
Maybe I can share a figure for that.
Okay. And
you can see it.
What do you want to mention? Yeah, Leon, why don't you go through this one?
Yes, I think this is a crucial figure because it shows what drives global warming, human-made global warming. And that's on the one hand, that's greenhouse gases in red. And here I've combined all the greenhouse gases since 1950 to 2023. And if you add it all up, it's called radiative forcing. And that's how much warming per square meter of the globe, which is 510 trillion square meters. How much warming these greenhouse gases cause, and that's in watts per square meter. And a watt is a joule per second. So how much energy is additionally forced into the system by these greenhouse gases. But then there's aerosols, which is the orange line. And the aerosols have a negative forcing, so they push the climate into another direction than the greenhouse gases do. The aerosols push the climate in a cooler direction. And if you add these two up, you have a positive forcing, so the climate is pushed in a warmer direction, but not as much as you would expect from only greenhouse gases. Because of the aerosols. So the aerosols have been reducing the warming from greenhouse gases. And then I've added here the satellite data from NASA, where you see there's a big spike in how much sunlight is being absorbed globally. And why is that spiking? That's because there's a decrease in sea ice, in clouds, and in aerosols. And aerosols reflect sunlight and make clouds brighter. So if you see this jump in the past years, which we think is because in a large part because of the reduction in aerosols, and that's why I think this paper by Smith and Piers Forster et al. has the aerosol forcing wrong. Well, I can cover that in more detail later. And then this shows the change in infrared radiation to space, and it's negative, but it means that more heat is leaving the planet in the infrared spectrum relatively to 2000 to 2010. So that compensates a bit for the increase in absorbed solar radiation.
All right. So that kind of shows it in kind of stark terms, and shows how important aerosols are, something that hasn't really been talked about very much until recently, until actually you, Leon, and Jim really started emphasizing the importance of it. As always was shown, I think, on the IPCC reports as being, well, there's a half a degree of cooling because of aerosols, and that was kind of the extent of the discussion or something. And it turns out I think that's like a minimum amount, right? It could be as much as like 1.5 degrees of cooling with aerosols. What would you say the possible ranges?
Yeah, so the IPCC range is that there is cooling in I think 2014 to 2019 relative to I think 1750. There was a cooling of about half a degree, and it could be as much as 0.8 degrees Celsius. And that's, we are now starting to learn. Of course, this already shows the very large uncertainty because it could be very small or it could be very large. But that already shows the uncertainty. And what is crucial to point out is that this cooling effect mainly happens over the northern hemisphere, where people live and emit air pollution and where they grow their food. So that's also where most of the risks are. So to phrase it as a global average, I think it doesn't translate too much the real effects of these changes.
Right, because there are regional changes.
And as I mentioned, so now we are only starting to see the effects, and that's crucial part also of our paper, of course, but also of the data. And there's many papers now coming out which show that there's an acceleration in global warming,
Right.
in how much heat is accumulating in the Earth system, and then also, of course, in surface air temperatures, which is only a small part of all the additional heat in the system.
And here is the graph showing that it comes from the recent paper, and it shows that the sort of violet line on the right side, the heading up faster than the green line. The green line was the linear fit from 1970 to 2010. And that's how fast we were warming up until about 2010. And then after 2010, there has been an acceleration. The point of this graph is, as pointed out in the paper, is that by 2030, which is the right side of the graph, the difference between what the global temperature will be and what it would have been if we had stayed on the green line is quite significant. In fact, the blue line is where we are. We're actually as high as we plan to be, quote, on average in 2030. We're that high right now, which is what, 1.6 something. The dot there, the black dot, was the 2023 yearly average. So we're way above that now, and yeah, it's all kind of amazing, right? Anyway, so that is a point that made in the paper, that global warming has accelerated. It says past 12-month temperature anomaly relative to the pre-industrial temperature, is currently 1.6 degrees Celsius, and that's an El Nino driven peak. Okay, so El Nino certainly contributed to that. But temperatures will decline later this year as La Nina kicks in. But 2024 will still likely be a record temperature year, even though La Nina will kick in by then. The El Nino was only a moderate strength, so a La Nina temperature drop is expected to be about 0.2 degrees C. In other words, going from the peak of the El Nino to the cooler La Nina, and that means we would hit about 1.4 degrees would be the, quote, cool. I keep saying, quote, cool. It's not cool, super hot, but cooler than it is right now.
Less hot than it is now, yeah. So I just put out the ECMWF Aero 5 data relative to 1850 to 1900, which is often considered as pre-industrial temperatures. And here you can clearly see, if you look at, for example, the 2015 to 2016, there was a super strong El Nino. And then you can see that this was breaking a lot of record temperatures. So that was the first time where we saw the annual average of 1.1 degrees Celsius. Before that, we saw such a warm year. And then 2016 was 1.3 degrees Celsius. But after that, there was never a decrease below this 1.1 degrees Celsius. So, and now we are at 1.5, and the average of the past 12 months is 1.64 degrees Celsius above pre-industrial. So we shouldn't be too surprised if we don't dive much below 1.5 in the years ahead. And I think that's yeah.
So, but saying that, let's say we did go to 1.4, if it did drop by 0.2, then we would be above. So El Nino brings us above the trend line, and La Nina brings us below the trend line. So when we're above the trend line, we're at 1.6, 1.64. Below the trend line, if it drops 0.2, would be around 1.4, maybe 1.45.
Yeah, you can see it easily here. So if you see it, this year was 1.5, last year was about 1.5 degrees Celsius above pre-industrial. And if we would have a 1.4 degrees Celsius, that's still warmer than any year before 2023 was.
Right.
So this is what we call the new normal and uncharted territory.
All I like to say is that we're at a record high temperature, and it's also the coolest it's ever going to be forevermore, except maybe slightly in the next couple of years might drop a tiny bit, but we're on the way up. So just to finish up the thought, when you average 1.6 for El Nino and 1.4 for La Nina, you get 1.5 is the average. And the average between what it is for El Nino and La Nina is, roughly speaking, that is the trend temperature we are at today. In other words, all this discussion, including the discussion we've had on this show with Michael Mann and others over the last weeks and everything, is, are we at 1.5? And this paper concludes that for all practical purposes, we're at 1.5 now, because we're above 1.5 right now. Yeah, we might drop. We're probably going to drop with the La Nina, but it's only going to drop enough at most to average out to 1.5. So that's pretty important. In other words, we're at 1.5, folks. That's what this
in December, Richard Betts et al. Published a paper saying, okay, when can we say we've reached 1.5? And one of the important milestones they mentioned was that when a single data set shows that there's been a year of 1.5 degrees Celsius or higher. And now we've had 4 data sets already, as far as I've seen, showing that there's a 12-month period, which they also count as a year. So any 12-month period as being above 1.5. And there's even, as I showed you, ECMWF is now for 12 months at 1.64 degrees Celsius. And I think there's more data sets showing this much warming above pre-industrial.
Well, so wouldn't that mean, wouldn't you end up getting 4 years in 4 months? Like you had 1 month, it's going to be a little bit higher. The next month's going to be slightly higher. And 4 months, you're going to end up with, quote, 4 years of data. I don't know if that is a valid way to do it.
No, it's just a year. So a 12-month period, that's what we call a year. And,
yeah.
And that's what Richard Betts in the proposed method of, estimating whether we've reached 1.5 degrees Celsius, say that counts as an important milestone, and to say whether we are reaching the point. And as we are in an accelerating warming system, of course, the past, it doesn't inform us very well about the present or future.
If I can point out
right
here that in the IPCC definitions of 1.5 degrees, and in the definition that's used in the climate models, or more specifically to describe what the climate models are telling us, 1.5 is defined as the 20-year average of the global average being over 1.5. So you can be, year after year over 1.5, and according to that very, formal, narrow definition, no, we have not exceeded 1.5, everything's okay. And so part of this is a little bit like the debate that the CDC and the WHO had about whether SARS-CoV-2 is aerosol. Because if it transmitted via aerosols, because if it was transmitted via aerosols, there are all kinds of rules about precautions that would have to be taken, which are, they're serious. It's not trivial to do them. They're costly. And it's the same deal here, because at least in theory, in the coming out of the Paris Accords in 2015, things would have to happen if we do in fact reach 1.5.
Yeah, but they do need to happen, because the agreement is not just about how do we say whether we are there or not. It's mainly about risks. It's about what risks are we willing to accept, and what measures do we need to take. And now that we see that the risks, which we are already seeing, are worse than most estimated, this means that the threshold maybe should be 1 degree, right? Because we already see that I've been, for example, in Panama, the Cunayala Islands, where these Native Americans live, and I was there in 2009, and they were already afraid that they had to leave their islands because they saw the effects of the rising sea levels. And now the first islands, they are being abandoned, and people are starting to move back to the mainland, because the sea level rise is too much for them to keep protecting the coast. And of course, those people don't have the means to build strong sea defenses. So those are those are like the canary in the coal mine, let's say, of the world climate effects of 1 or 1.5 degrees. But that's already happening. So we need to work harder. We are already at the point where the risks are too great. We are now seeing a hurricane category 4 earlier developed than anyone expected. We saw the one in Acapulco last year, which destroyed Acapulco so the effects are already there. So for all intents and purposes, as we say, so the 1.5 is that, or the safe. We've crossed the point where the climate is safe, and where humanity developed and is able to withstand. For example, the agriculture is already impacted heavily. In the Netherlands, we've just had almost 1,500 millimeters of rain in 12 months. We're not prepared for this kind of extreme weather, even in the Netherlands. So let's say, let alone in other countries.
That's right. And I think a few important points to make there is that when averages go up a little bit, extremes go up a lot. As one example, we've gone up 1.5 degrees so far, but even back when it was really closer to 1 degree, when you took a look at extremely hot summers, which were defined as the average summer temperature in a particular place that was more than 3 standard deviations above the 1951 to 1980 mean. In other words, a summer so hot on average, the average summer temperature was so hot, it would typically only happen 1 in 1,000 times back in 1951 to 1980 in that time frame. Those extremely hot summers are now happening not 1 in 1,000 times, but 1 in 5 times. That's a 200 times increase, or a 20,000% increase in just 50 years. So the average temperature went up a little bit. The extremes, these very hot summers, which we're seeing all the time now, of course, are happening really on a regular basis. Same thing for precipitation. As the Earth warms 1 degree, we add about 7% to the water vapor in the atmosphere. Now we're at 1.5, by the way, but even at 1, it's 7% more. And that doesn't mean you just have rainstorms that are 7% stronger. You end up with rainstorms that are crazy hot. Yeah, go ahead, Leon. I mean, crazy high, not hot.
That's indeed, again, the global average.
Right.
And we don't live in the global average.
That's
we mainly live in the northern hemisphere mid-latitudes. And this shows the sea surface temperatures. This is a figure shared in the Hansen et al. Email and mailing. And then, so what we show here is that, especially, of course, here you see the latitudes, and these are the years since 1990. And then you see that the sea surface temperatures around the world, and then you see this is the tropics, and you can see that, for example, this is 1979 to 1997 to 1998. You see this the strong El Nino forming, and then you see warm El Nino periods in tropical Pacific show up, and then here you saw another very strong El Nino in 2015 to 2016. Of course, and then here again in 2023 you see an El Nino form. But if you look at the higher latitudes, here you see that these are warming very fast as well. but they don't cool down. So we in our paper we show that especially in these latitudes where air pollution was reduced over the past decades and over China, but especially in 2020 from shipping, 2015 regionally from shipping, but in 2020 global shipping emissions of sulfur reduced by about 80%. You see that this region, where we also see a very strong increase in how much sunlight is being absorbed because less is reflected back to space, we see that in this region is really heating up very fast. And I also get the question, okay, why do we only see the effects of the regulation happening in 2023? But that's not what we see. We see it already happening in starting in around 2020, and then only getting worse over the latitudes. Why most people only see it, and that's what I wrote about it over a year ago, that many will only now start to realize what's happening, because now we have had an El Nino develop, and then the global average increases. The global average surface air temperatures start to increase, but we already saw it from the data, from satellite data, from ocean heat data. We already saw this big increase happening. But now that the sort of threshold from 1.5 is these milestones are being broken, and now more people are starting to realize what's happening. And here is another visualization of that, where you see these are monthly data, and this was 12-month average. So you see the monthly data again over the latitudes and years since 2010, and then you see that, and these are from 20 to 60 degrees north, and from the tropics, 20 to 20 degrees south and north. You see this red line, which is the pink, the average of the pink. Here you see a strong El Nino, and now we are at about the same height, but that's because there's also a warming trend. The El Nino is less strong than it was in 2015, 2016. Mm-hmm. But you see in the northern hemisphere mid latitudes, you see the same increase as the El Nino. But this we shouldn't expect this to decrease anymore, because we changed the radiator forcing over the northern hemisphere mid latitudes. And so we should expect what Makiko Sato, our co-author, she called a northern hemisphere mid-latitude El Nino, which is permanent and might get even worse. So we should consider that this is the new normal which we have to deal with, and this is the North Atlantic, where we now had a very strong hurricane forming. As we speak, it's still developing. It's already a category 4. I don't know if it will turn out to be a category 5, but
the earliest one ever.
It's the earliest category 4 ever, and
yeah,
if it will
ever
be, yeah,
period.
I think in this region, yeah. And of course, last year we had Otis form hitting Acapulco, and there was also a very rapid development. And so, of course, if you see this enormous increase, that's an increase in sea surface temperatures of the whole North Atlantic, which is 40 million square kilometers. And it takes 3,000 times as much heat to warm ocean water than it takes to warm the atmosphere. Same volume of air. Then a 0.6 degrees Celsius of sea surface temperature increase over such a short period in time. That's really crazy, but it's not completely unexpected if you've been looking at the data, and it does indicate that there's potentially a stronger forcing of this aerosol reduction, the sulfur emission reduction, than most thought possible. And that, of course, more heat in the system. I look at it from a broader perspective. So if you have more heat in the system, you should expect indeed higher temperatures of the atmosphere. Atmosphere can hold more water. Storms can have more heat to power and to create stronger storms with more precipitation. So, from a broad perspective, this is really what we should expect. And it's important to realize that these sea surface temperatures are globally are probably much higher even than they were during the Eemian, so the warm period 120,000 years ago, when sea levels were 7 meters higher than they are today. Because we are now at a greenhouse gas forcing, again this forcing, which we haven't seen for maybe I'll show you here. This is a recent publication. So we are now at a force at the greenhouse gas concentration, and of course, so this shows the bottom red line shows the reconstructed CO2 concentration in the atmosphere, and of course there's uncertainties. But if you look, we might have to go back about 9 million years to see the same greenhouse gas concentration as we have today. So that's a completely different planet when sea levels were about 67 meters higher than they are today.
67 meters.
Yeah, 67
200 feet.
Yeah, I don't measure things in feet, but
roughly speaking.
Yeah,
and
and
it bears mentioning that the rate of change that led to that warm period was nowhere near the extremely rapid rate of change, geologically speaking, we've shocked the system with. So feedbacks which may occur, which did occur then, are not the same just dynamically due to hysteresis to the kinds of feedbacks that could happen now.
Well, also we're going to be at 560. In a blink of an eye. I mean, in a
if you take into account the other greenhouse gases, and we don't know exactly what the greenhouse gas concentrations were from. We don't know exactly how much methane there was in the atmosphere 10 million years ago. So it's difficult to compare this to CO2, but just as an indicator, we would have to go back even more than 10 million years in the past, and then again, so then we are already at a forcing. If this is comparable, we are already at a forcing that's that where we could get 67 meters of sea level rise, and that's why it's so crucial to reduce the radiative forcing, reduce greenhouse gas concentrations, and consider what we do with air pollution. Because if you don't consider that, the policy still, even if you don't consider it, is still policy which has an effect on the climate, whether you do it consciously or not. And I think that's crucial to take into account.
Yeah, and by the way, when you showed the mid-latitude warming, it's amazing how it starts at exactly 2020. It's kind of shocking, actually, that you pass a rule that takes effect in 2020 and everybody wanted to wait until 2020 to implement it because it costs them more money for lower sulfur fuel, but they did it. They got ready for it, and then in 2020 they started using the fuel, and then at exactly 2020 it started up. We didn't see it because the La Nina below it in the equator region was offsetting that heating. But then when the El Nino kicked in, we not only saw the El Nino, but we saw the mid-latitude warming on top of that. And that's why and everyone says, like, how do you explain these crazy temperatures? It's right there. There it is. You can explain all the crazy temperatures.
And it's reproducible. So anyone can check this data, and they can also check the satellite data from NASA and try to reproduce just even this simple graph. And I think that that science, if you want to do science, try to reproduce what we show. And if you say it's not because of what of aerosols or change in aerosols, come with a different reason why we see this increase. And because this is what.
Have you heard any good ones? Any cogent explanation besides shipping aerosols?
I keep asking, and I haven't seen I haven't seen anyone come up with a reason why this there is such a huge increase in how much sunlight is being absorbed by the planet, let alone in northern hemisphere mid latitudes. And I'm still very much open to alternatives. We don't have an agenda. We knew that there were climate models showing that the effect might be strong before 2020. There were models showing that the effect might be not so strong. We didn't know, and we were just waiting for the data to become available as we are running this inadvertent aerosol experiment, as we called it. And now the data is starting to come in, and it's rather worrying. So, and we should, I think the preliminary, I think we should consider that this is really happening and this is a permanent change, and act accordingly, because that's what the precautionary principle requires from us. So, because there's many people saying, okay, the null hypothesis is that this is just natural variability, or that the null hypothesis that there's no acceleration in warming. But I think that's really the wrong way to look at this, especially from a risk perspective. Because if there's a fire alarm going off in your house, and if there's smoke, and if the door feels very warm, you don't say, okay, the null hypothesis is that there's no fire, so let's go back to sleep, right? So I think that's considering all the risks that are, we should really take this very seriously.
I'll tell a little story which is directly related to that in human nature. I was staying at my dad's apartment in Fort Lee, New Jersey, a couple decades ago, and he wasn't there, but I was staying there. And then at 3 a.m, the fire alarm went off, and I said, "Oh, I'm gonna stay in bed. It's probably just going to turn off in a moment," but it didn't turn off. It kept going. So I thought, "Oh God, all right, I'm going to get up." I got up, got dressed, went downstairs to the lobby. I am the only person in the lobby, and the alarm is, by the way, still blaring everywhere in the building. There's, I don't know, it's a pretty big apartment building, a lot of people there. So I knock on the door of the supervisor who's in the lobby, and he begrudgingly comes out too. And now he and I are the only people in the lobby. And then the fire department shows up. But back then, at least in Fort Lee, it was a volunteer fire department. So they only send somebody in a pickup truck and a radio, kind of to see if we really should wake everybody else up and send them to the fire if there is one. So now there's just the 3 of us. Again, not a single other person in the apartment came down. And we look on the panel and it says, oh, okay, the garbage room, there's the alarm is going off there. So we walk over to the garbage room, we open the door, and all this smoke comes billowing out of this room. And there was a real fire, and not a single person except for me got up. And it just shows I'm just emphasizing what you said. And by the way, the reason that I got up is probably why I'm doing this climate program today.
Yeah.
It's like I don't.
And even you didn't get up in the first place.
The bystander effect, is something that is really powerful. Oh, someone else will take care of it. Oh, it's probably nothing. That's optimism bias. Well, it's probably nothing. No, when it comes to existential threats, you want to assume the worst and hope for the best.
Exactly.
So assume the worst, act on that, eliminate that threat. And then, even if you're wrong, you still did the right thing.
Yeah.
And we're just not, we're not doing. And by the way, speaking of that, I do want to cover this Supreme Court decision. Maybe in a sense, it's in this context a little bit. Let me share the news article. 1 second. Where is it? Did I switch away? One second.
Maybe I can just cover one more.
Oh, okay, go ahead. Yeah, you go ahead while I go find the other one. Okay, go ahead.
Because this is data which was published yesterday as well. So this is the global satellite data from NASA, which shows in black the absorbed solar radiation, and in red the outgoing long-range radiation. And I think 2 months ago, I had a poll on my Twitter feed and asking people, okay, do you think the outgoing long-range radiation is increasing? So more heat is radiated to space. And of course, greenhouse gases retain heat radiation, so they stop heat going to space. So you would assume that there would be a decrease, and 75% thought there would be a decrease. But as I show you this red line, it's increasing. But there's much more heat radiated to space in the infrared spectrum. But there's also much more sunlight being absorbed. That's the black line. And the difference between these is increasing if you just see the trend, right? So if you look at the of course, if you have higher temperatures, it's called the Planck feedback, because the temperature in Kelvin to the fourth power.
Fourth power.
Yeah, so you can estimate how much heat is radiated from a body if the temperatures increase, and then so you should expect when something gets hotter, it will radiate more. So it got hotter in 2016. There was this very strong El Nino. You saw that the amount of outgoing long wave radiation was reaching a peak, and there was also quite an increase in how much sunlight was absorbed. Because of course, if it's warmer, there's also less clouds forming, because they evaporate faster. And again, the atmosphere can hold more water, liquid water, so there's less condensation. So in at that time, compared to now, there was in this 12-month period up to April, there was an imbalance. So the difference between how much heat is radiated to space compared to how much heat is absorbed of 0.81 watts per square meter. And now the difference is 1.23 watts per square meter. So there's 0.42 in this data watts per square meter more heat accumulating in the Earth system, even as temperatures are much higher. I think 0.3 over this period, 0.33 degrees Celsius higher, which indicates a decadal warming trend of 0.4 degrees Celsius. So even if there's a record rate of warming and a record rate of heat radiated to space, there's still much more heat accumulating in the system as there was only 8 years ago.
Yeah, it's by the way, that I want to emphasize what you said.
Changed,
oh,
right?
Go ahead.
Sorry, this difference between these two lines is what produces the Earth's energy imbalance, and this is the rate of change. This is not warming. This is the rate of warming. This shows the rate of heat accumulating in the Earth system according to this NASA satellite data, and that agrees with the ocean heat content data and with how much heat is accumulating in the atmosphere and how fast ice is melting. Everything is accelerating. No matter what anyone tells you, everything is accelerating. And that's what the data shows, and that's what we should act upon. Not to some hope what anyone hopes the data shows, because what the research shows, what all the publications on this show, is that there's a strong acceleration in how much heat is accumulating and also in the surface warming.
Well, I think almost all climate scientists agree with
no, they don't.
But not all, but most.
They all agree. I can show you if you want.
Yeah. But back on that graph, so I helped, as I mentioned previously, I helped Jim Hansen with his 2012 TED Talk, and he wanted to talk about the Earth energy imbalance back then, and the value back then, only 12 years ago, was 0.6 watts per square meter, which I said, Jim, no one will know what that means. And so together we worked out that that's equivalent to 400,000 Hiroshima-sized bombs going off every single day. That's how much energy that 0.6 watts per square meter is equivalent to. Now it's about double, right? We're what, 1.2, or, you know, roughly speaking, at 1.2 something?
I think we are, so that was, the present point is 1.2, but I think the trend is about, I think the past 4 years were, from the satellite data from NASA, is about 1.4 watts per square meter.
So that's a million Hiroshima atomic bombs going off every single day. That's how much energy, extra energy is coming into the earth and is going out. And by the way, I want to just emphasize something you mentioned in passing that I think goes by very quickly and people don't pay attention to. The earth radiates heat away from the planet proportional to the fourth power of the temperature. So in other words, yeah, in Kelvin. And as the temperature goes up, it greatly increases the, it's one of the things that helps keep our climate balanced. It's the most important negative feedback that keeps us, with a stable climate is this fourth power. But we're doing everything in our power to put up so much greenhouse gases that we sort of even overwhelm this fourth power feedback that would tend to keep us cool. We're adding the greenhouse gases and getting rid of the aerosols and doing these other things to really screw things up. But that's a really important feedback.
For people who are not used to using Kelvin, that's about 273, and then plus the degrees Celsius is 288, and that multiplying that by itself 4 times. And then with that number, you can calculate how much radiation is going to space. It's a bit technical to go into the details there, but it just shows that if the temperature increases a bit, because you multiply the temperature in Kelvin 4 times by itself, that means that the amount of radiation going to space increases by a lot.
And it's the only thing I remember from my astrophysics class in college is that luminosity equals 4 pi r squared sigma t to the 4th, which is related to that. Okay, so anything else you have there on that? Because I wanted to cover a little bit of this Washington Post article and about the new Supreme Court thing. I want to relate it a little bit to what we're talking about. Then we have a lot of people here. I'd love to open it up to questions as well.
Maybe just to close this subject off of accelerated warming. I think we've reached the point where we should just stop talking about whether it's increasing or not. It feels to me like we're discussing whether the Earth is flat or not, and we keep having the same discussion. So let me just show you what I've shared before. This is it. Share sound. You see it?
Not yet. Leon has started. Yes.
Maybe you know this gentleman here on the left.
Good looking guy.
And on the right, there's Gavin Schmidt from NASA. Mm-hmm. He has the job James Hansen had before him at NASA GIS. And you can listen to what he has to say.
It does seem clear that there's been an acceleration in this Earth's imbalance, and that actually matches the ocean heat content changes that we've been able to perceive as well. So we have multiple data sets that all kind of suggest that has in fact been.
We go back a bit, but so this is a publication. Karina van Schuckman was also a co-author of the paper with James Hansen. And it says robust acceleration of Earth's system heating observed over the past 6 decades. So you can see, yes, observed. Yeah. So there's not climate models, and here you can see from 2002 to 2020, the rate of increase from all these different data sets has increased a lot. I think that's 0.4. So this shows here 0.4 watts per square meter per decade of acceleration in the rate of warming.
Been increasing.
The ocean heat content is an almost perfect linear ramp.
So if someone says it's a perfect linear ramp, that means that there's no acceleration.
Which implies actually a fairly stable planetary energy imbalance. And one of the conundrums that we're trying to work out within the community is
that the one you published there? Did I get the right one? Is that right?
No, yes. I'll let me put it.
Okay, you can put it up.
We're displaying. I'll go ahead and display.
So this is the data from the paper, which he's this person is going to show, which he published. And he's going to a different source of the paper, but this is the data. This is what the data shows. The series data. So this is the NASA satellite data and the ocean heat content data from that data set, which shows that there's a strong increase in the rate. So not a straight line, but the rate of change is increasing since 2005. And 2005 is important because that's the year from which there's a global observation system, or near global observation system in the oceans of these Argo float, these buoys, which measure the temperature of the oceans and the salinity.
I'll bring up our, actually the easiest thing to do is to just go to the Guardian.
Well, we called
So
little
again, Gavin
Tizzy.
admitted that I wouldn't say he was in Jim
Uh-huh.
Hansen's
All of
camp
this.
at all, but he was basically saying,
So
we've
I'm
had
gonna
an acceleration.
share. So
Mm-hmm.
there is, so that's
This single data set keeps being used to imply others are lying about the accelerated warming. But this data set has been updated and now does show acceleration, which is in line with the NASA series satellite data for the period since 2005, since which near global ocean heat content data is available. It looks like their old quality control system had removed more extreme higher temperatures than it maybe should have.
What are the odds of two boys failing? Roland. Make that three.
a linear ramp, ocean heat content data. There's no statistical evidence of an acceleration in ocean. It's the rate at which we're warming the planet and changing the climate that poses such a threat to all of us.
So Leon, I want you to edit all of my climate chat programs into little 2-3 minute things.
No, but why I share this, and it's not to attack someone, but I think it's the last point is crucial, because what is said is that it's the rate of change that causes such a threat. It's really the rate at which the planet is warming which is causing such a threat. And if scientists say that the rate of change is stable, while the evidence, even their own evidence, shows that the rate of change is not stable but is rapidly increasing, I cannot not mention this, because that's where the risks are. Again, even they say themselves, that's where the risks are. So we should acknowledge reality. We shouldn't deny reality. We shouldn't ignore the fire alarm that's blaring in at the bottom of your apartment building because it's inconvenient to get out of your bed. We know it's inconvenient to get out of bed if it's nice and warm, but you don't want to burn alive. So and if the professionals are, if some of the professionals are ignoring this, I think that's very, very dangerous. And I don't say that lightly. I say it's gross negligence, because they have a duty to inform. They have the duty to inform accurately, because the risks are too great. And it's just one apartment building which is at risk. It's really the whole planet.
The whole planet. Yeah, I was going to ask you, because Zeke published that chart that that Michael was using, but he had the wrong baseline, and then he republished it with the right baseline, the pre-industrial baseline, clearly showing, I thought, that we're at 1.5 right now. And Zeke himself said, no, don't say that. He was saying we're at 1.3, and I didn't even understand his own chart.
Yeah, so that's a different discussion. I think that what I like to focus on is the global heat uptake, because that's 90% of the heat goes into the oceans. So that's where most of the evidence is. What the rate of surface air temperature change is interesting, and of course it's used as a threshold, or as a goal, or a limit in the Paris Agreement. So it's useful, but there's much more data and much stronger data from the other points. And indeed, if someone says this is the line, we are at 1.5, we are at 1.3, well, the evidence shows that this same line, because it shows that if you look at the right baseline, it shows that we are at 1.5. It shows clearly that they're just changing the baselines to defend what they want to say. So, and you can't have you can't eat your cake and have it too by saying, yes, the models show acceleration, but we are not at 1.5 if we just change the baseline, but I didn't change the baseline. That's not honest.
Strange. One of the questions in the chat, let me ask one in the YouTube chat is, when will all of the scientists, like Zeke and everybody and Michael, have to acknowledge the accelerator, and like how much more data? I think Hansen was saying, it's very soon, because if we just drop to 1.4, then it kind of proves we're at 1.5, which means there was an acceleration.
So from the precautionary principle perspective, they have to do it as soon as now, as it's clear. Even I think it should have been mentioned much sooner, and it should be discussed much more, that when you reduce aerosols, that there will be more regional warming, because that's where most of the risks are. And I know it's very inconvenient to talk about it. As I've mentioned before, Al Gore made a movie called The Inconvenient Truth, and he didn't talk about one of the most important drivers of climate change, especially regional change, which are these aerosols. Every climate model has aerosols in them, otherwise the model breaks. So every climate scientist knows about aerosols, but it's just averaged out, and it's often approached like it's a greenhouse gas, or it's evened out with methane. If you just reduce methane, then it compensates for the changes in aerosols. But in practice, methane is going up very rapidly and aerosols are decreasing very rapidly, which causes extremely rapid rates of change, especially in the northern hemisphere mid-latitudes. And then to go back to the question, when do people, or when does anyone, should anyone acknowledge it? Because I don't, whether they will, that's up to them. That if they want to not tell the truth, that's not up to me whether they tell the truth or not. As I showed you, their own data shows acceleration. The own publications show it, but they keep saying we are lying. They keep implying that we are lying, but the data shows, and it's clear. Anyone can check the data if they want.
Okay.
They can check the publication I shared. They can look it up for themselves, and then I think we should act upon what the data shows, not on some false hope by whoever. Right.
By the way, you mentioned Al Gore, which reminds me I should do some of my YouTube stuff here and just mention to everyone to please subscribe and like this video so it gets shared, but also just to give a little update on upcoming shows. We're supposed to have David Keith actually this week or last week, who's at the University of Chicago, an expert in climate intervention. Think of geoengineering, that type of thing. He's having trouble making it on Sunday, so I think we're going to end up doing a special edition show, not on Sunday with him, but next Sunday morning at 10 o'clock Pacific time, we're going to have a return guest, George Marshall. George is the one who wrote the book, Don't Even Think About It, Why Our Brains Are Wired to Ignore Climate Change. It's very much like no one waking up when the fire alarm is going off, that type of thing. It's a great book if you haven't seen it. It's been around for a while. He's working on a new book on a different subject, which we'll get into next week. It's very interesting and exciting. So great. It would be great to have George back with us next week. And the week after that, we're going to have Ken Berlin, who was the former head of the Climate Reality Project under Al Gore. And also now at the Atlantic Council, basically a progressive think tank on energy matters. And so that'll be great to talk to Ken, and Ken's friends with Al. And I asked him to ask Al to come on the program as well, which he said he would do. We'll see if that works out. So that's a little bit of upcoming shows. Again, please subscribe. If you're not subscribed, you can hit the notification bell to find out about upcoming shows, which again are 10 o'clock on Sundays, at 10 o'clock Pacific time. Again, with a few special ones every now and then. And anyway, so now getting back to our regularly scheduled program, as they say. Let's see, I did, again, wanted to cover this thing, at least briefly. This is a article on a recent U.S. Supreme Court ruling about environmental rules. Long time ago, during the Reagan administration, the Supreme Court ruled that cabinet level, cabinets level things like the Energy Department or the Environmental Protection, government entities could set regulations, and as long as they're done reasonably, they could be implemented. And back then, under Reagan, this was sort of an anti-environmental thing, which meant that if the EPA made a rule that wasn't very good at maybe cleaning up the environment, that rule could stand. But then what happened? Later administrations became more progressive on environment, wanted to use EPA and everything to implement rules that were good for the environment. And this was the Chevron Doctrine, as it was called back then, that said that the regulators could implement these things and they would stand as, they'd stand the test of the law. And now the Supreme Court has sort of overruled that, saying it's not always true that a government agency acting in a reasonable way can set a rule that will stand. And it gives Chevron and others a chance to go to court and fight this. So it's something that hurts the environmental regulations. And of course, the current Supreme Court's not really too keen on doing anything for the climate or government or democracy or anything like that. But I wanted to make the point that while this is a negative thing and people could really harp on it as something like, oh my God, if we don't fix this, we're really screwed. I want to make the point that we haven't really been taking any serious action on climate anyway. So this is really kind of in the weeds in a sense, that there's so much we need to do that is so far beyond what we're even talking about right now. We have to cut our fossil fuel emissions dramatically, and we're not. We need to do research into carbon removal and geoengineering, solar radiation management, these kinds of things. We have to do this on a really important scale, as Lynn pointing out. We have a really big problem here. And so while this is important, I think if you focus on this, it's kind of missing the point that the government, even if this rule wasn't changed, is doing hardly anything to fight climate change. Yes, we did pass the Inflation Reduction Act, which was truly the largest climate bill ever, but mostly promoting renewables. And when you promote renewables, you end up with more renewables. You don't necessarily end up with less fossil fuels. I do think we will have less fossil fuels simply because renewables are so cheap, but it's not happening at the rate that we need to. So anyway, I just wanted to bring up this the Supreme Court thing, and we can make it part of the discussion. And I see Eric raised his hand, but if anyone has, if you do have a question for myself or for Leon, then we'll get to you in a second, Stacy. Then use the hand raising function for that. And let's start with Stacy, and welcome, Stacy. Great to see you.
Hey, good to see you. Thanks for being here, Leon. And oh, did he go? Elliot? Oh yeah, Elliot's still here. And Eli, of course, always. Well, I did want to read, because this feature in YouTube Live, which I had never seen. Nadia was the first person that used it the other week, and I didn't get a chance to say her thing. Her first one was, I mean, she's paying to chat. So I don't know if you guys are familiar with this, but it's like, like she's paying to make sure her comment is seen. And so I feel compelled to echo her comment, because she always has great things to say. Anyway, the first was, the super rich who dictate all refuse to pay and always will. Therefore, 1.5 degrees will never be acknowledged. And then the question she had is, isn't the rate 10 times faster than the Permian Triassic? How would that make what's shortly en route compared to then?
Leon, do you have thoughts on that? That we're moving towards these extinction level events. This is actually in the global warming of the pipeline paper, that I think we're on track for forcing by the end of the century. That would be equivalent to the, I forget which extinction event, but one of the major extinction events.
Well, I don't know if I gave the comparison of the meteorite that ended the dinosaur eras. Okay, that might be comparable. course, and it depends a bit on what time frame you use. If you use 100 years, I think the cooling from the air pollution from this meteorite reduces heat uptake. So it's a bit of a joke, but we are, of course, causing a mass extinction event. We've already killed most of the megafauna around the world in the past 10,000 years, because all the other glacial periods and warm periods didn't kill the megafauna. And then when we spread around the world, all the megafauna died, and we built huts from skulls of mammoths and stuff. So there's quite a lot of evidence that we are responsible for that. And now, of course, we are looking in more detail at what's happening, and we see species dying at rates which are much higher than the natural changes. And for example, the most of the coral reefs won't be able to survive these temperatures of the oceans. I've read somewhere that the Eemian sea surface temperatures, even when the sea levels were 7 meters higher, the sea surface temperatures during the Eemian were only half a degree Celsius above pre-industrial levels, and we are already much higher than that right now. So if you cause such rapid change, you should expect many things to break. And we are reaching, as I showed you already, CO2 concentrations not seen in millions of years. And we really don't know what happens if you cool a planet down over millions of years and you just change the temperature, you change the thermostat back to 10 million years ago. And that, of course, that caused very rapid change. Aerosols were reducing that a bit, but we are rapidly reducing the aerosols, cleaning up our air pollution, which will show us the real effect of these greenhouse gases in the atmosphere, as long as we don't decrease these greenhouse gas concentrations, which, as far as I can tell, is not happening. We're doing the opposite, of course. Some say somewhat hopeful that we are the greenhouse gas emissions are stabilizing. I haven't seen enough evidence for that, and even if we would have, that doesn't mean much, because we're still emitting 4 billion tons of CO2 every year, which is enormous.
Okay.
So that actually dovetails into sort of. So Dan, it was very brief on Chevron, because I'm guessing you're saying, what's the matter? Because we're not doing it that way. Chevron would only matter if we were doing the things that we should, that it might hack away at the efforts we were trying to make. Is that what you were saying?
Yeah. The Biden administration, by the way, I should say, I met him once when he was vice president at a fundraising thing. There was a small number of people around, like 30 people. We got to ask him questions. So I raised my hand, as you might imagine I would. And I asked him a question about climate change and the Obama administration not like doing as much as it could. And he looked at me and said, "Oh, you're one of them." That was my reaction. That's the one time I spoke to Biden. And back then, that's how, to think about it, wasn't that long ago. That's how climate activists were viewed, as this strange group. Okay, what are we going to see, Leon? Is this a video?
I love that you have this stuff at your fingertips. It's awesome.
What's it say?
Yeah, he was already talking about it, so I thought I'll just get this up.
That are the Saudi Arabia of natural gas, the Saudi Arabia of natural gas, the Saudi Arabia of natural.
So what Obama is saying there is that it turns out that we are the Saudi Arabia of natural gas. And here, this shows the exajoules of global energy supply from US shale gas since 2000, compared to solar, wind, nuclear, and LNG over the first 20 years of growth. And you see that the United States is indeed the Saudi Arabia of natural gas.
The Saudi Arabia natural gas. The Saudi Arabia of natural gas.
Just leave
Aren't we
them
the
there.
Saudi Arabia of everything? I mean, we're the largest oil producer on the planet and the consumer. I mean, it's
And this guy is very green too, right?
No country would find 173 billion barrels of oil in the ground and just leave them there.
Yep.
So
I
I
like
think-
to say this, folks, is why we're all going to die. Is this?
Yeah, but I think it's quite important indeed to note that if they say so, the other parties, the other party is very dirty and they don't take climate change seriously. But then you hear the party that's accusing the others of not being very green. Here, when they are at these oil companies meetings, when you hear them say these things, then I think they're not more green, but just bigger hypocrites.
okay.
Well, the U.S. is, I mean, Obama had an all of the above energy policy, was proud of it. It's not like, oh, we did it by accident. It was a conscious effort, and we increased fossil fuel production more than like under any other president or something, and yet was a great speaker on climate change. He gave great speeches about the dangers of climate change, yet on net did nothing for climate. In fact, you could argue, I mean, did a few good things, but increasing fossil fuels is a bad thing, and that outweighed everything. Same is true with the Biden administration today, is that they approved the Willow Project, and they're approving gas leases and things like that. You can't do that when you're actually serious about fighting climate change, right? So no one, getting back to that Supreme Court thing, we are not yet serious. And by the way, Jim Hansen, when you read his things, I've known him a long time, and he's quite a conservative guy, but he now is saying we have to do solar radiation management. Believe me, it's like the last thing in the world he would ever want to have to say. But he also, you could tell when he's asked these questions, but well, when are we going to do it? Something, he says, well, when we get scared enough, we're going to go do something. And he's saying there's going to be young people, right? He's essentially giving up on the current generation of political leaders and saying, and I say the same thing too. I mean, we're choosing to fail. And if we continue to choose to fail, we will. I mean, you keep failing, you're going to fail. But at any time, we can instead choose to succeed. And once we do that, there is a lot we can do. Now, will it be fine from then on? No. I mean, it's not, we've already failed for so long that things are going to, get worse before they get better. But there are things like solar radiation management that can temporarily cool the earth. We can do carbon dioxide removal, which people think we can't do. But there's a lot we can do. But first thing, before we can do any of those things, is we have to decide to choose to succeed. We haven't done that. And my fear is that the climate impacts, which are sort of the physical, the heat waves, the floods, whatever is caused by shifts in climate, I'm concerned about the human society systems failing in light of this added pressure from climate faster than the climate, in a sense, changes, right? Human society is a very fragile system. We saw in 2008, someone pulled a card out of the deck called subprime mortgages, something that no one ever even heard of before. And it caused, a global recession and almost a depression over one little stupid thing that no one ever heard of before. And now imagine climate pulling all these cards out of the deck all at one time. So I'm concerned about our governments. We have to act soon so that we still have stable governments to implement these programs. Because if you try to implement it when we're sort of in a Mad Max situation, well, then you're in a Mad Max situation. So you
52 card pickup, anyone?
Yeah, 52 card pickup. Okay, we got some questions from the audience.
Just one thing, Claire. Justin Trudeau, do you know what year that was?
I think 2017. But so the actions are still. So I think it's if someone says these things, if they say what did he say? no country will find 173 billion barrels of oil in the ground and leave it there. And so if they say that, I think that's one thing, and it's honest. But if you look at their actions, they support what he said there, right? They went on to build all these huge oil pipelines. They went on to build these desulfurization systems to get the sulfur out, to build these huge sulfur pyramids, and to ship all the fuel through these pipelines to the coast, and to sell it, because that's the actions they have. And so if they talk about, whether they talk about getting all the oil off the ground, or whether they talk about nice mitigation project of climate change, it doesn't matter really, because what they do is what happens, and they just keep emitting greenhouse gases like there's no tomorrow. So I think that's what matters.
Sadly. Okay, thank you so much.
Sorry, I was on mute. Let's move on to some other questions. First of all, Eli, if you're there and have a question, I know. Wait, I know he was traveling, so okay. Eric, let me. I'm called. Hold on a second. Let me make it possible for you to unmute and start your video. 1 second. There you go, Eric. Welcome to the stage.
Hey, look, Leon, I have enormous respect for you, but I do want to make the quick point that we ought to have at some point a conversation about how movements actually work in the United States. It's not that, oh, we just elect wonderful Democrats or something, and then they go do the work for us. That's never how it works. It's you, I think the way it works, and I should look for a historian, and Dan, if I do, I'd be interested in, you elect some politicians that were less horrible than the other party, and then you get in the street and you force them to do what you want. So the election is only a tiny part of the success. We didn't get out of Vietnam, by just electing. The elections are part of it. So if you still have one party that's climate denying, I think that's relevant, even if it's still going to take a movement, right? So I don't know, so anyway, that was one point. The other point was the question I put into the chat, that the Constitution isn't supposed to be a suicide pact, right? So Andrew Johnson, for example, ignored Winchester versus Georgia. The idea that we should actually be demanding that our politicians ignore insane Supreme Court decisions. Most ridiculously, I think, is this major questions doctrine that has no place in the Constitution. It's not in any law. They just kind of made this stuff up. And since the court can't really defend its own decisions, doesn't have an army, doesn't control budgets, at some point, maybe it makes sense to tell our politicians they have to ignore decisions that are so toxic. Those are my thoughts. Thanks.
Okay, well, yeah, I mean, who was it? Was it Lyndon Johnson or somebody? Someone came up and said, I want you to do this. And he told them, make me do it, Right,
FDR, that's the famous. I love that.
Yeah.
I love your proposal. Now go ahead and organize and make me do
it. Yeah. So, yeah, and that was my point about the decision is that look, until recently, the decision wasn't there, right? The governments could regulate appropriately. Were they using it to address this huge problem we have with climate change? No. They were using it to make it look better. I mean, they were doing some things, but these are things around the edges, not, if you're serious about climate change and you understand that fossil fuel emissions are what's driving it, the most obvious policy, we talked about this a few weeks ago, is to phase out fossil fuels. It's an obvious thing. It's like you don't need a PhD, to figure this one out. You got a problem, you're digging a hole, stop digging, literally stop digging and stop emitting fossil fuel emissions. Now, can you do that tomorrow? No, but you can do it over a fairly short period of time The world will adjust. And fortunately, the replacement is cheaper than the thing you're doing that's bad. So you'll actually end up saving trillions of dollars in the process. But this is not even something that's discussed. I mean, it's not like we're debating this in government right now. How fast should we phase out fossil fuels? What we do debate is how fast should we subsidize renewables? Not a bad thing. It's just that it's not the same thing as getting rid of fossil fuels. So we know,
Okay,
we know the problem. We just have our head in the sand. I mean, I don't know, like, a lot of different ways of putting it, but
I guess what I'm saying is that Leonard Leo and his team are trying to do the best they can to limit democracy and the ability for democratic processes to shut down fossil fuels and stuff, right? That is putting these like completely ahistoric, completely inexcusable things like the major question doctrine in place. So we
have a separate problem here.
Taking them seriously.
We have a separate problem of the U.S. I mean, the U.S. government's a very corrupt system, right? We're just inherently corrupt. We all know it. I mean, companies are allowed to give money to politicians. It's official. It's all legal. Everyone knows it's happening. It's kind of weird. Oh, really? Companies can give money to politicians? That sounds like a conflict of interest. But, so we have a system that's inherently corrupt. Everybody knows it is. We're not doing anything about that. And then it goes beyond that there's like literally bribing Supreme Court justices and things like that we're now finding out about. But, so it's true. I guess my question is, will damage from climate change, which now everyone is starting to recognize is actually caused by climate change. You see every day the river of water flowing down the center of some city, washing cars away. And I mean, it's almost every day. And whether it's US or Italy, I saw Italy yesterday. I mean, literally every day. This is not normal. I mean, it used to happen once in a while, sure, but not on such a constant basis. Will that damage get the public to rise up fast enough to demand action? So far, the answer is no. But there will be some point in the future where the answer will be yes. The question then is the government still stable enough to do something, or do we really wait too long? I hope the answer is that we don't wait too long. The good news is we have fantastic things we can do that would be very effective, save us tons of money, clean up the air. I mean, it's like all positive stuff, except we do have these, vested interests that make a lot of money on fossil fuels and other things like that that control the government. So it's a big question. I guess we'll talk a little bit about it next week, also with George Marshall, who really about how our brains are not really wired to address long-term problems like this, but he might have some insights as well. But anyway, thanks.
I think that overthrowing Chevron deference and this major questions doctrine, right, are an attempt to kind of block future democratic action. And so I think it's very important to understand them and have strategies to deal with them.
Well, I mean, one of the strategies, you pass laws, right? This had to do more with government entities authorized by law being able to set regulations that were not directly set by law, right? That was sort of what this was all about, as long as it was done in a reasonable way and whatever the rules were. So you can always go and pass the laws and still.
Right, you're talking about overthrowing the filibuster, or how do you pass laws when you have the filibuster?
Well, yeah, I mean that's certainly one way to do it, right? I mean, to start off. But you have to start off by electing people that even want to try, right? And I mean, it's a very sad state in this country that someone who's, convicted felon and plus a lot of other stuff convicted of fraud and sexual assault and everything like that is still running neck and neck with someone else. I mean, we're in a very bizarre time. Someone did predict that 2028 will be the first year of a presidential election where climate is the major issue, or I'm sorry, a major issue, I should say.
I thought it was 2024, Dan.
No, 2028. because
Well, let's see.
2028 is when enough damage will occur on a regular basis that people will start to get fed up with it. It's not
I'll have to
enough
go
yet.
back and check
Especially in the United States, by the way.
It's not
Yeah,
November yet.
Yeah. But
Right. Still time.
they asked
Yeah,
one
but-
question on climate at the debate. But anyway, it's not enough yet. People are really able to optimism bias, denial. I had, by the way, an interesting discussion on Twitter yesterday about denial. Some people who were really depressed about the climate situation. And I made the point that, but look, I'm in my 60s here, and I actually believe that I'm going to die someday. In fact, I believe everybody on this Zoom is going to die someday. And knowing that, having that information doesn't mean that you have to go and be depressed for the rest of your life. In fact, it should be the opposite. You should enjoy your life and realize that you have limited time. And so the fact that a lot of people are going to die from climate change, which probably, well, first of all, it's already happening, so it's a reasonable statement to make, and will continue to happen. That doesn't mean that you should just go around and be depressed all day. I mean, you should be concerned about it. You should fight to change it and all those kinds of things. But just like you're going to die someday, that doesn't mean that just because you have this, quote, bad information that you should be depressed all the time. So my suggestion to that person was to use a little bit of denial when it comes to, just like you use denial about your death. No, we don't go around thinking, oh, I'm going to die someday. I can't go out and do anything today. My God, I'm so depressed. So just have a little bit of a little dollop of denialism for the climate as well, so you can help enjoy your life going forward, even while you fight. Yeah,
I think what's crucial there is to be honest about it.
Mm-hmm.
So, because I've experienced quite a bit of things of loss and things in past years, and I think the first step in grieving or in losses or in hard things is acceptance, not denial. So I think you should really, whether it's a death or if it's cancer or something similar, if you deny it, that will not help you. It's counterproductive. So you have to accept the reality for what it is and act accordingly. That's in my experience, the best approach, especially if denial makes it worse. Right? There's, for example,
sure.
Yeah, but
although some people think that denial, the human denial, so we're the only species that knows we're going to die. I think. Maybe, I don't know, elephants. Who knows? Maybe some others have an idea about that. But the fact that we really know we're going to die, and that the fact that we have denial is what allowed us to advance as a species, because otherwise we would have been like depressed all the time. And
but
so
it can also kill you. So there's, for example,
sure.
If you look at there's research on what happens if people have cancer and if they use natural medicine or alternative medicine, and of what you might expect is the ones that use alternative medication are much more likely to die than the ones that don't. Why is that? Because many of the people who use alternative medication don't use the real medication or don't use surgery. Of course, you can look into the studies and see a lot of caveats, but I think that's what we're also now seeing, that people like natural approaches to the problem. It's nice to talk about planting trees, right? It's nice to talk about about natural solutions to climate change. But we don't live in a natural world anymore. We live in a world that's we've tripled nitrogen fixation over land. We've increased the greenhouse gas concentration. We've doubled the greenhouse gas concentration relative to CO2 before the Industrial Revolution. So there's not much natural about the current system we're living in yet anymore. So I think the solution, we should be honest about that. If we talk about sunlight reflection methods, then of course it's not natural, and of course nobody wants to do it. But if the evidence suggests that the alternative is extremely rapid warming and mass dying, for example, if that's what the data will show, then you can say, okay, let's let it happen, and that's a political decision, and people. But then people should be honest about that, I think. Because
by the way, don't get me wrong. I'm totally for being honest.
That's also what deny is. If you deny the warming effect of aerosols, to go back to the subject at hand, if you deny that because it's inconvenient, the deny will cause very rapid warming, which you are not prepared for because you were denying what's happening. And I think that if you do it like that, if you say, okay, it's not natural, it's inconvenient, it's I don't like it, I will ignore it, I will deny it, stage of grief, denial, then you have to live with the consequences. And everyone which you didn't inform, or everyone you are responsible for with your science or with your policies, will be impacted by your denial. And I think that's a really important caveat to what you just said.
Yeah, and again, my point was, if you're going around depressed, therefore not like living your life, But by the way, a great way to not be depressed is to get engaged in climate action. It's very invigorating. You feel like you're working on something important because you are, and you feel like you're a little more control of things than if you just sort of watch the world go by. And so I do recommend to anyone who's feeling upset about the climate is get involved. You can start a YouTube channel if you want, but I mean, there's so many easy ways. Join Citizens Climate Lobby. I'm sure there's a local near you, and they're fighting for carbon tax and other climate action. There's so many groups. Our Children's Trust just had that success, or Justice. Many places that you can go to get involved. And if you get involved, then it becomes something that's depressing to something that's actually exciting, that you're working on the most important problem in the world, and it's a good feeling, not a bad feeling. So that's like a little bit of what I was trying to get at there. That's Stacy.
Yeah, I just wanted to put some things in the suggestion box. Leon, I heard you talk about nitrogen in the soils, and I had one of my banker friends talk to me and say about how, because he's hopeful we're going to come up with the solutions, and he said, and he likened it to, we weren't going to be able to feed enough people, but then we came up with nitrogen fertilizers, blah, 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 whatever. And I feel like soils is something we could probably have a good show on if we, because we don't talk, we talk about it in passing here, but I think having a soils show, like one chat might work. And another, I just read here, so you must follow David Ho. And I've always viewed him in like Zeke and Manland, but he said, to oppose research on climate solutions for fear of mitigation deterrence is like opposing medical research for fear that people will not choose healthier lifestyles. Not having climate solutions or healthcare will simply lead to more human suffering. And I was like, oh, so maybe we want to give him a call. I don't know.
Yeah, we've talked about that. I totally agree. Like, by the way, if you assume that taking action on climate change will prevent emissions reduction, that the moral hazard argument, well, by definition, you're assuming that we're not going to take serious climate action. We're going to keep on muddling along like we are, and asking fossil fuel companies to pretty please reduce their emissions, and not tell them to reduce their emissions, but just kind of ask them in a nice way, hoping that they're going to agree. Well, if that's your climate plan, you don't have a climate plan, right? So if we do get serious and we choose to succeed, then we have policies in place that require emissions reduction. And then when you look at it that way, carbon removal and sunlight reflection methods, all those things are just in addition. They don't have any negative effect because we have policies that require the right thing to happen. Right now, we don't have that, of course. And that's why everyone's hoping to get these like ad hoc little things going, to make little changes that they are in the right direction, and they think that we did it. But we actually do have to get serious about climate action and actually have an integrated set of policies that require us to move in the right direction. We haven't done it yet, but I hope we will soon. And climate damage is going to help us move in the right direction, because it really doesn't care what we think politically. The Earth is going to do what it's going to do.
Yeah, we're going to be handing out Ozempic to the masses to get rid of our, of our problem, rather than, put down the tub of ice cream,
And I put it another way. I said there's certain things that we must do. And by must, I mean, if we don't do them, we suffer unacceptable consequences. That's kind of what, like, if I force you to do something, I can, put a gun to your head and say, you have to do this. So there's a lot of things we must do. We're not doing those things.
No.
We're instead choosing unacceptable consequences. That's what we're doing so far. And partly because, they happen a little bit later. So maybe I can get away with it. Maybe it's like kids who suffer, it's like, there's a lot of reasons. We'll, again, talk to George Marshall about this next week, but go ahead.
Yeah, I think, Stacey, what you mentioned David Ho, and you mentioned camps. I don't really see this as being certain camps who are for or against something, except for maybe some people who are even denying their own data. But I think that those are really the exceptions. Most really are scientists are. Very few scientists are against scientific research. I haven't seen many of those. There are quite a few academics who have voiced opinions and written about that there shouldn't be any research on intentional reflection of sunlight, stratospheric aerosol injections, etc. That's mainly academics. There's many teachers, let's say. Those are. You can discuss whether they are scientists and to what extent they are scientists. They are not the ones doing the research, so it's quite strange that you have some academics saying to scientists that they cannot do science or they shouldn't be paid to do science, right? Especially if you see what's at stake. And I've asked some of them, can we still do research on aerosols, right? Because aerosols are the biggest uncertainty within climate science. And there's some tests being done to understand what the effects are of shipping aerosols by spraying some sea salt in the atmosphere. And then those projects are being blocked. But that's crucial. That kind of research is crucial to understand what the role of natural aerosols is in the climate, and what the role is of our unintentional air pollution on the climate. And we need to know that also to understand what the warming effect from our greenhouse gases will be when we start to reduce our aerosol emissions or even greenhouse gas emissions, right? So we need to understand what's driving our changing climate. And if some are gatekeeping the science, I think that's really that reminds me of times of burning of witches and that sort of things. You need really, really good arguments if you want to stop people from doing scientific research on subjects.
Okay.
Especially if the alternative is that some will apply the research without or apply the technologies without the research. Can you imagine using of nuclear weapons without doing any research on what the effects might be, right? That's what
let's see. By the way, we have
the whole atmosphere.
We have Elliot here. Elliot, I see you're unmuted. Would you like to join the conversation? I also saw you ask a question earlier about the global temperature, which I think is off. You were mentioning you think the 12-month temperature was with El Nino 1.41 in 2024.
Yeah, I'm here right now. I don't know if you can hear me.
Yeah, we can hear you. You can also turn on your video if you want. You should be able to do it. There you go.
Yeah. There I am. Hi. From cold Santa Barbara with the picture of the snow in the background here. Yeah, I don't really have a question. I more have a comment if you will allow it.
Please go ahead.
Sure.
So, I have really struggled with the 1.5 question. I've written quite a bit about it on my blog, and sort of in the middle of it, I went through all the different methods that people used that I could find in all the different literature and looked up, estimates dating back a decade. And the most recent one that I sort of concur with is to take the previous 10 years with the next 10 years as they're modeled and to, derive an average temperature from that, which is actually the one that, Professor Mann kind of tried to use as well.
And Zeke too. Yeah.
So that's not there's no official method out there, right? So we can't say it's anything in particular because one method is sort of as good as another right now. And, that's distressing at a very gut level, but
actually, I think that's not a valid method. And let me give you an example. Let's say you have a thermometer in your house and it's really hot outside and you had the air conditioning on and you shut the air conditioning off. And now you want to start measuring hour by hour what the temperature is. Then you're doing it. You're measuring very carefully. Everything's going fine. And then someone opens all the windows and all the doors. And then you keep making measurements. All of a sudden, the temperature goes way up because the doors are open.
No, I know the aerosol. I heard you use that analogy before, and that's a great.
Why isn't that valid? You changed something.
But we don't have future estimates on the impact of the aerosol. That's sort of equal guesswork to using modeling at this point. I mean, the future is kind of chaos as far as that goes.
No, we have data.
No, if we actually want to make a statement about today, and I heard you use this before as yet another methodology, let's refer to past La Niñas following this El Nino and take some sort of forward average. Well, I actually did that. I went back and I did a 365 running temperature in order to do this calculation rather than just sort of a day-to-day. And I saw if you take the 365-day running mean, from the peak of an El Nino to a trough of a subsequent La Nina, right, was 0.36 C. So I would be hard pressed to give us an absolute under, assuming we're at 1.64 right now, right, an under of 1.28 is historically within, the realm, even though almost certainly it won't go that low. And also, if you look sort of at those numbers, then that minimum happened 3 years after the max. So, at the worst case scenario, all right, the worst case scenario is we're at 1.64, we go down to 1.28, we take the median of those, which is 1.45, and that 1.45 is a year and a half from now, the midpoint between today and the trough of that La Nina.
What do you mean by worst scenario?
That's the best case. Definitely over 1.45 in a year and a half.
Okay.
All right.
Keep in mind, however, this El Nino was not the strongest El Nino. This was a moderate El Nino. So
right, and
the drop will not be as much.
1972 was not the strongest one either. So it's
but you're now comparing a year where there was a very different rate of warming.
Oh yeah,
but that's the whole point. You can talk about models, or you can talk about scenarios, or you can talk about the past 10 years. But the whole point is that we should look at the data, right? Wait, let me please finish. So what we do when we look at the data, and you know this data because you looked at it yourself
every day.
Look at that exactly. That's what I mean. You see that the rate of heat uptake has doubled over the past 2 decades. That's what the NASA data shows. That's what the NOAA data shows. And then if you go back to 1970 and say, okay, if we just use that, that's not the world we live in anymore. We live in a world where there's much faster heat uptake globally. We've seen the past year that there's an increase in how much sunlight is being absorbed. That's what the data shows, of 2.3 watts per square meter compared to the first decade of this century. And that's all this heat is already in the system, and that will cause the surface temperatures to keep being elevated. And that's what Dan also says. So I think it's a good analogy, because we put a lot of heaters out there because the greenhouse gas force is much higher, as I showed you already. The energy imbalance is much higher. So why look at what the world was 50 years ago? You said talking about 1970, whether at the current data and what we should expect from the data, and then even, for example, looking at 2016, that El Nino was less strong, was stronger than now. So maybe we should see less cooling, right? Because the peak was higher, so we should see less cooling than we saw after 2016. I think that should be our assumption when we look at it from a risk perspective.
Right. And I would just say that my definition of the trend is that half the time, I mean, if it didn't keep going up, which it is going up, but where we are in time, that you would assume that half the time it's above that trend and half the time it's below. And we know that El Niños bring you above. We know that La Niñas bring you below. So I'm not saying it's a precise exact number, but if you average the two, your El Nino and the next La Nina, which is happening very soon, you're going to get a rough idea of what the trend is. The trend is likely in between those two numbers, and probably around half the way between. It's not some super precise thing, but I think the focus on using, as Leon was just saying, this long-term data from long ago that doesn't apply anymore. It's like spending time on math rather than really looking at what's actually happening right now. And what's happening right now is different than what happened 10 years ago.
So
let me sorry.
Yeah,
go ahead.
Elliot, go ahead, Elliot.
I mean, I disagree with both of you.
Okay.
So first of all, 50 years, of course, is not relevant today, but you were the one who used, the trough of a La Nina to after of a La Nina after an El Nino in your own argument. So I was just saying, based on that argument, a worst case is 1.45C, right? So I'm not, if your argument is from a peak of an El Nino to a trough, then 1.45C. The other thing is,
but the worst case is higher, right? I don't understand why you call it the worst case.
Well, right, it's yeah, okay. The best case is a 1.45C.
Okay.
So, that is almost exactly the same as my separate analysis where I did this sort of the decadal, I actually mapped the acceleration so that I could use the data to get that. I mean, it's almost spot on. That's
where my confusion was, because you call it the worst case, and I think if you call the best case, so that maybe depends if you want to, if you want the things to, if you want to be.
Let me just finish here. So 1.45C, the world's in bad enough shape that even as a doomer, I don't like to exaggerate where we are right now. My own research puts us, I don't want to call it research. My own analysis puts us at 1.5 in 2027. All of the models, every model, and I know there's arguments against the model, but has us going over 1.5 between 2027 and the early 2030s, I understand the confusion around this issue, but I don't think it's such a big point that we need to say that my method is the right method and your method is the wrong method.
That's what we started with. It's just a global average, and it doesn't mean much,
right?
Especially to most people, right?
Right.
I think that's why Hansen keeps using the phrase "for all practical purposes." He's not even trying to say, "I'm telling you exactly what some technical definition is." Look, it's above it then, it's below it then, halfway in between is one. But we're at 1.5, guys, for all practical purposes, and maybe we all agree on that. But it doesn't mean.
It's just I am so profoundly frustrated and have been for a long time that this was not formalized in and around the Paris Accord, that we're doing this guesswork today.
But otherwise they wouldn't have agreed. If it wouldn't be so flexible, they wouldn't have agreed upon it.
But I'll go back to open your eyes. I am not a scientist. I don't play one on TV. I just hang out with you people every week. And I'll tell you what, open your eyes when you see the flooding, when you see the heat, when you see the fires, when you see all of this stuff that is happening, the sinkholes, like the earth is done. It is done. We have put too much into the system, and it is only going to get worse because we are not reducing what we're doing and we are not taking things out of the system. And I don't know how anyone, like the whole, like, I love y'all, I do, and I am there for the math, I am there for the science, but I really want us to do whatever we can to rattle all the cages and shake people by their ankles or whatever and get things moving in the right direction, because
Sure.
we're not we're not.
Well, I agree with that, but I think one of the interesting, when we've had this discussion long ago about 1.5, is it a good thing to go over 1.5? I think it is, because it says, look, guys, we're obviously not really doing anything to fight climate change. This is just an indication that we're not, and we're on our way to 2. And everyone thinks that somehow 2 is acceptable. Like if we were able to stop at 2, the world would be okay. No, that's an utter catastrophe to go to 2. As we're seeing with 1.5, all the damage at 1.5, whether, we're plus or minus 0.1 or something, forget that. We're roughly at 1.5 now. And I think we all agree we're going to be over it by the end of the decade for sure. And we're seeing things that are totally unacceptable, things where our infrastructure, which was designed to handle, 3 inches of rain, in a day, and it's getting 30 inches of rain. I mean, it's not even close to possible to handle that kind of thing. And 2 degrees is not just X% worse than 1.5. There are whole sets of things, AMOC collapse, which we've talked a lot about here, which changes everything, screws everything. And we're headed toward that with hardly any discussion, except for specialized places like this and a few articles and research things. We're not taking this whole situation seriously. And my point is that a plan to stop at 2 degrees that ends in catastrophe if you're successful, and by the way, chances of you being successful are tiny, but even if you were successful, 2 degrees would be catastrophic. So therefore, that's not a good plan.
Can I respond to, I think what Stacey was saying, what Elliot was saying. I think paraphrased a bit, but Elliot was saying we shouldn't make it worse than it is. So that, in a way, jokingly a bit, the truth is better.
I agree with that.
And Stacey was also saying, okay, maybe we looked at the math a bit too much. And I think what's crucial to understand here is that we do need to look at the math. We do need to look at what's really happening. We do need to show how bad it really is, because that determines how high we have to build our dikes. How fast will the sea level start rising? How warm will India get when they reduce their air pollution? There's billions of people depending on the science getting this right, and the science is getting it wrong. I don't like to debate the science with people who've looked at it for a decade longer than I have. But if their own research shows that it's wrong, I should inform them about it. If they say this, the aerosol forcing is now the lowest it has been in 8 years, while we had reduced all this air pollution over the oceans, we should call it out, especially if we see that the Earth is absorbing a huge amount more sunlight, right? And if they call their paper indicators of climate change, and they don't show one of the most important indicators of climate change, the NASA satellite data, if they don't show that, we can say the truth is bad enough, stop calling them out, stop attacking these scientists. Or we can say, what is the science? What does the data show us? Be honest about what the data shows, and don't push it through the peer review process, and tell the engineers this is uncertainty. It might be much worse, because that's what the data shows. We don't know why these sea surface temperatures over the northern hemisphere, mid-latitudes, are so extremely hot right now. It might be aerosols. We better assume that it is, because that means that we get a hurricane category 4, maybe 5, hitting the Caribbean in June or the 1st of July, right? People need to know that. If you lie to them, if you say the truth is bad enough, the truth is bad enough. Buy my book. The truth is bad enough. I don't like to make it worse than it is, right? It's fucking lying, and you're going to get a lot of people killed. And I'm sorry to say it like that, but that's the honest truth, right? If this is what, if all this heat is going to cause 1 million or 1 billion people to die, I'm not going to sit here and say, yeah, I don't want to exaggerate things, even though this is what the data is showing. I don't want to make people feel uncomfortable because I don't like people to be uncomfortable. I don't like it if someone tells me they have cancer, but I'm going. That's the truth, and I'll have an honest conversation. Do you want to use chemo? Yes or no? No? Okay, that's your decision. But that's for an individual. If you make the decision that nobody should use chemo, and everyone should just die from natural causes or which are not really natural, that's on you. That's on you. That's what you causes to happen. And I think that's really crucial to point out.
The
By the way, I want to
say,
add.
the only thing I would say to that is, though, that you're talking about, and I get the analogy, but when you're talking about an individual accepting treatment versus something that has to do that the world is then accepting the treatment, it is different. And the only thing that will actually cure us is to not get it in the first place, and that is by.
Well, we already have it. You can lie about having it. That's the problem.
Right.
If you lie about having cancer, if you tell people no, you don't have cancer, and and this herb which I just took from my garden, if you buy it, you'll definitely never have cancer. That's the analogy, and it's very close to reality what we're now experiencing.
Touche.
It's about risks. If European Environmental Agency writes a paper of 200 pages where they talk about risks, about climate risks, and they don't even mention the word aerosols, while that's what causes most of the risks. I can show you. If you in your model you don't take aerosols into account, there's 1 degree Celsius of summer warming which you are not showing. That's it. And in 2022, 60,000 people in Europe died from extreme heat, because they are not being informed accurately about the rapid changes that are already here. And that's those negligence. I don't have a better word for it, because that's reality, right? That's data. That's the models are wrong, and the data shows that the models are wrong.
I was going to mention, by the way, that Jim Hansen, in this recent white paper that we started off discussing, does have a little section on climate anxiety, and he says that it's being driven by climate scientists being honest. Actually, I mean, when they are honest, it drives anxiety because the truth is scary. And he then says, I guess he's going to try to be somewhat optimistic in his upcoming book, Sophie's Planet. I don't know how, but he's going to try. And then he gave the example of the court win in Hawaii as an example of some positive news. But I do think when we talk about fear versus hope, I just think it should be honesty. We should be honest about what we're doing here, what's happening, and then we can make decisions on how to react. Let's see, we have a couple people. Keisha, you were raising your hand before, but it's lowered. Would you like to ask a question? I can ask you to unmute if you'd like to still ask your question.
I would. Can you hear me?
Yeah, and you can go on video if you want.
Yeah, how do I do that?
You just go to
should be at your lower left.
There we go. Go ahead. There we go.
It is. Hello. So I've been listening. I'm a physician, triple boarded pathologist, do a lot of diagnosis. So the cancer diagnosis thing really resonated with me, but the whole pandemic did, because it's very similar to this. The thing is that people don't necessarily want to listen. And when it hits home is when they really take reaction. With the whole pandemic, a lot of it also had to do with messaging, because we were trying to prove these certain things. We had all these papers, we had all this evidence of what the treatment could be. But when you're talking to the layman, if you know your audience, that necessarily isn't what's going to hit them. That's not when we go to the Hill and talk to the lawmakers. That's not what is hitting them. It's going to really resonate with when they're going to make the decision. But when you tell them, listen, it's hitting home when their loved ones started to die, when it started to hit the pocketbook, right? And we've had over 1.1 million deaths, and it hit the amount that we cost in our budget. then that's when they started to realize maybe there's some truth. The reason why I link it back to what you're talking about with the climate change is that that degree number is important, but the effects of it are very important with public health. The Chevron overturning actually really affected, and then the American Heart Association, the American Cancer Society, they all wrote a rebuttal because it's affecting insurance companies and it's affecting health. 38 to 40% of the heat-related deaths are because of climate change, and are doing. 38 trillion of the budget worldwide is due to the effects of climate change. We're seeing vector-borne diseases now in places they shouldn't be. Toxioides should not be in places it shouldn't be. We're seeing spillover events. I mean, it's bad, the amount that it's affecting public health. So I wish that we could push more and put the messaging, whether it's who's messaging, about the effect. Listen, it's killing our people. Listen, people should not be having, people complain, why are all these mosquito-borne diseases, why are we having dengue fever and all these rises worldwide? And that it really is directly linked to heat-related deaths or to climate change. I understand the part about the science and the papers, because I think we need to keep that to us, right, in between our audience. But we go out front facing sometimes, we have to hit them with the punch and with those bullet points, and maybe put that in the bullet points, but that sometimes is what they're like, oh God, what are they talking about? And it goes over their heads. And we're still struggling in public health with that.
Well, I think, by the way, you make some great points, and I think you'll enjoy the discussion next week with George Marshall, because he makes the point that people don't make decisions based on data. They make it based on emotions. And basically summarizing what you just said. So we're going to have a big discussion about that next week. And I certainly agree. And we've done other programs with David Fenton, climate change is a communications failure, on and on. And I agree. There's lessons to be learned between the pandemic and what's happening with climate change. The pandemic was, though, that you could die next week. So it really got people, they did things they never thought they could. I mean, the good news is, you ever say, oh, we'll never get rid of fossil fuels. Oh, no one would ever accept that. If you told everyone, oh, by the way, you're going to stay at home for a year and not go to your office or school for a year, because they'll go, yeah, you're crazy. What are you talking about? And yet we did it. There, the fear was a week from now, which was effective. Climate change is a year, 2, 10, 20, it's a little hard to say when.
Except for heat-related deaths or fires and stuff like that.
Yeah, but not me necessarily. Yeah, it's happening. It's happening right now, of course, right? It's how do you use honesty? I don't want to use fear. How do you use honesty about climate change to get the public engaged? You ask the public, do you care about climate change? They say yes. You say, do you want action on climate change? I think 60, 70% in the United States say yes. Are you going to vote on climate change? Well, no. So there's different levels that we have to deal with, and it's the I always say that when it comes to climate science, we know almost everything we need to know. Leon and others are helping us understand more, but we actually do know everything we really need to know. When it comes to solutions, we know everything we need to know. That's not, we're going to learn more. We're going to learn more about all these things, but we could start now very aggressively if we chose to. So what's happening is not the science, it's not the solutions. It's the human systems. It's politics. It's marketing. It's communications. It's leadership. It's all of those things that we're failing at. It's not the climate science or the solutions. Both could be better, of course, but they're really where they need to be for us to do the right thing. And we're just, as Kevin Anderson says, choosing to fail. It's a choice. And we're choosing to fail, and I hope that we're going to choose to succeed soon. Thank you so much for your comments.
Thank you, Leon, as well. Thank you.
And Michael, I see you have your hand raised.
Yes, I'll just want to add on a point. Is not so much the climate data alone, because I think in the right hands, good policies can be made. But I will give an example. So, like, there was a time where I was given the chance to talk to the Ministry of Environment and Climate Change in Malaysia. And all of us suddenly just, after the whole briefing, all of us, politicians, NGOs, businesses, all come together and sit at one table. And that is where the climate anxiety starts, because that is where we realize actually the biggest problem is not so much that we don't have solutions or the fact that we don't have resources to do it. It's the fact that corruption and greed and poor governance usually hamper a lot of these processes, even within international organizations like the UN. So, and just to let you know, my wife worked for the UN. So just to let you know that she's seeing all the behind the scenes, and it's not very optimistic from the way things are going. Just to add on to the point.
Well, it's certainly not optimistic the way it is now. Again, a line from my TED talk, which was from 2014, so it hasn't happened yet, but I did predict that we're going to go from impossible, when it comes to action on climate change, we're going to go from impossible to inevitable without ever passing through probable. In other words, right now, it's like gay marriage. Gay marriage was absolutely impossible, and then it happened. Like it was never a time where, oh, it might happen. It went from impossible to happen. And then I think Biden actually said something that triggered a discussion, and then boom, all of a sudden it happened very, very quickly. I think that recognizing climate damage as being from climate change, that this is not normal, this is all changing, we can't, our infrastructure won't be able to handle it, et cetera, et cetera. It's going to trigger at some point, not yet. But maybe, again, next week with George Marshall, we'll have a better understanding of that. He's looking at that kind of thing. I want to thank everybody. It's really great discussion. Leon, especially thanks to you for bringing us so much information and data, and also for the work you've been doing with Jim Hansen on, you're really, people might not know this, but Leon sort of is the key researcher on the whole ship aerosol thing, and that he brought that part to the global warming in the pipeline paper. That was really a landmark paper last year. And we've been talking about some of these white papers, these communications that Leon and Jim Hansen do every couple of months now, and giving little updates on what's been happening. It's super important, driving the narrative, which is great, shifting, getting the rest of the, by the way, you did a great job, because a year ago, like we had Gavin and Zeke and everyone say, oh yeah, everything's accelerating. But you go back and look a year before that, they weren't saying things were accelerating. They're all saying yeah, we of course they're accelerating. We always knew they were accelerating. But you go one year back. Yeah, that's
what they say.
So congratulations.
If you look at what they were saying a year ago, they said it was linear. Yeah.
Yeah.
No,
I went back and looked. I went back because I had Gavin on as and Zeke on. So I looked at what they wrote a year ago, and it was like, oh, they didn't talk about that. So congratulations on that. You and Jim and everything are doing some of the most important climate research out there. It's
thanks.
So much. Very often, when at least it used to be, you read about climate science, and it was like this far off in the future thing might happen. This is like real time climate science, right? This rules change, aerosols drop, bam, and it hits like right away. It was hidden for a few years because of the La Nina, and then bam. And it's just strange to be sort of experience real-time climate science happening.
Yeah, that's why we call the aerosol. That's why we call the aerosol termination shock, because you terminate the emissions, and then there's a rapid warming, which we say is we use a threshold of about 0.2 degrees Celsius per decade of additional warming, and I think that's what we are now experiencing. If you look at the last El Nino and the current El Nino is if you look at a decadal time scale, it's over 0.4 degrees Celsius warmer than it was in 2015, 2016, and that.
0.2 of that at least is aerosols.
Yeah, it used to be 0.18, the rate of warming between 1970 and 2010. So if you also include the other aerosol reductions, because the greenhouse gas concentration increase forcing is linear, so then the aerosol reduce, so that increases the. So it's like it's the one is pushing the climate into a warmer direction, the other is pushing climate in a cold direction. If you reduce that, you have this shock effect.
And
that's what
Jim
we-
Hansen talks about it as our Faustian payment being due. Our deal with the devil, the payment is coming
but
due.
he didn't expect it to be that we had to pay so much of it on January 1st, 2020. And that's what we now, that's what we had to do. And now we're starting to
So I'll end with my prediction based on what you said, actually. My prediction is that we are going to use sunlight reflection methods or solar radiation management or solar geoengineering, whatever you want to call it, to purposely reduce the temperature. And we're going to do it soon. I don't know exactly what soon means, but when the public finally rises up and says, wait a second, we don't like this. This is terrible. You must do something. When that happens, let's say 5 or 10 years from now, the only tool in the toolbox that will have an immediate impact on reducing suffering, the only choice we'll have will be SRM, solar radiation management, because if we decide at that point, okay, guys, we're going to start reducing our emissions dramatically now, we're even going to do carbon removal, we're going to do that on a rapid pace starting right now, you won't notice the impact for another 20 or 30 years, but SRM you'll notice next year. Because of that, just from a political point of view, I think that politicians are going to be forced into implementing SRM because the public will rise up. The only choice they have that the public will even notice they did something will be SRM. So I don't know what your thoughts on that, but we can go out with that as well. Okay. All right. I want to thank.
It's a scenario.
Go ahead. It's a scenario.
It's a scenario, and I think it's a more likely scenario than many of the scenarios that are out there.
Yeah.
And whether it's a political choice, very much driven by the real world effects of rapidly accelerating climate change.
Mm-hmm. It's also something that's relatively easy to do. I mean, we're relatively doing some heavy lifting, but compared to reducing our emissions to zero,
it's comparable to developing a vaccine within 2 years.
Yeah, something like that. Yeah.
I think there's I don't know the numbers, but I think trillions were invested in fighting COVID, right? So globally.
Well, actually, it's only if you include all the subsidies, absolutely. But the estimate for cost for implementing SRM is in the billions of dollars. Yeah, just billions.
That's what I mean. So if you compare it to the costs for COVID, it's really nothing.
Okay. Well, with that, I again want to thank Leon. I want to thank Elliot, Stacy, Eli, and everyone else who participated. Again, please like this video. Please subscribe. Also, next week, we have a guest, George Marshall, who wrote the book, Don't Even Think About It, Why Our Brains Are Wired to Ignore Climate Change. I have the copy of the book right here. I'm actually the one who came up with the title name, by the way. We're going to interview George, but he did this book long ago. A great book if you haven't read it. It's actually one of the best books on climate change that's not about climate change. It's about us. It's about our brains. It's not about like aerosols or greenhouse gases. But he's working on something new, which is really interesting, but we'll talk about that next week. The week after that is Ken Berlin, who's at the Atlantic Council, the former head of the Climate Reality Project, which is Al Gore's group that trains all these people to give climate talks. I was part of that back in 2006, 2007. And I found it to be, we'll talk about it next week, a little too sugar-coated, and I ended up doing my own talks, which I called at first a very inconvenient truth. And unfortunately, I think I nailed that back then. But it'll be a really great discussion. We will do something with David Keith. It probably won't be on a Sunday, so we'll announce that on Twitter. Follow me at DanMiller999 on Twitter to find out when what's upcoming. And I want to thank everyone. It's been longer than normal, but I thought a great discussion. So we'll see you next week, Sundays at 10 o'clock Pacific time. Again, next week with George Marshall. Thanks, everyone. We'll see you next time.